Welcome to MathLink Academy, where we connect the dots. I am Mr. C, and I'll be covering this section, a continuation of finding areas of polygons. The one we're going to talk about is triangle. And so in this particular lesson, we're going to look at two different formulas how to find the area of a triangle, and then look at a complex shape and see how we find the area of that complex shape. So let's get started. Areas of a triangle. So this is our first formula. The area of a triangle is equal to 1/2 the product. When we're talking about product, multiplying of the base and the height. So we multiply the base times the height and then take a half of it. The height is a line perpendicular to the height. So the height is a line that's perpendicular to our base. So let's look what we have here. So that should be base, really. This should be our base. And that's why Mr. C here to make sure those slides are right. So this is the area, and this is your first formula. You want to put that in memory or write it down. Area is equal to 1/2 base times the height. Again, if we're looking at a triangle, here's a triangle. Let's say this is our base down here. Then our height will be a line from the vertex hits perpendicular, that's the key, to the base. And that would be our height, okay? Let's look at a particular problem here. So we have a triangular piece of land shown by the grades and seed that costs at about $1,000, 550. What is the grading and seeding cost per square foot? So we got to figure out the per square foot. We got to figure out how many, what's the area of the triangle. And we're going to look at this particular shape. So I got to give you the area of the land, and then we're going to figure out how much or what is the grading and seeding cost per square foot. So here's our triangle, and notice it's a special triangle. It's a isosceles triangle because we have two sides that are equal, 160 feet, two sides, and the other one is 210 feet, which is our base. So we're going to use that 210 as our base. So in other words, we're going to use the height from C. If you notice, C is on the top. And this will be our height right here. This length is our base. So we already know our base is equal to, you can write this down, 210. Now we just need to find our height. Now notice that we actually got another triangle inside the bigger triangle when we use this height. And so what we end up with looking or seeing is that we have 150, that's the length here, and you say, oh, excuse me, 105, and you may want to say, how did you get 105, Mr. C? I got 105 because I took half of the base, which is 210, half of 210 is 105. Because it's an isosceles triangle, we can do that bisector. Let's call that, it's called a bisector. And then we also have this 160 as a hypotenuse. So this is a leg right here. There's another leg, and we got a hypotenuse. So what we want to do is find that height using Pythagorean theorem. Now we already know the base is 210, so just put that in your memory. We'll put that up. We'll come back to that later. So we already know the base is 210. We just need to figure out what the height is. So when we set this up, and we let the slide do the work, but when we set this up, we're going to look at 160 squared, that's our C square. We also have a side or a leg square plus our unknown, our height square. And so that's what we're going to set up and then solve for h, and then use our area formula to find the area of the triangle. So there's two steps to it. We want to find the area, and then we want to find the grading and seating costs per square foot. So let's go to our next slide and show you what we have here. So we got to use Pythagorean theorem, and this is what we said earlier. We set this up, we find each of the squares of each of those numbers. Then we subtract on both sides 11,025 square feet on both sides, which gives us 14,575 square feet. And then you take the square root because we got to figure out CE or H. So in this case, this would be our height once we do our math, 120.73. In this case, it's just feet because it's height. It's no square, it's just feet. So we know what the height is. We know what the height is. The height is 120.73. So if we go back to our slide, we can see what the height is. Now, all we have to do now is incorporate our formula. Again, our formula is A is equal to 1/2 the base times the height. We know 1/2 the base was what, 210 times our height, which we just found. So let's let the slide do the work for us. That's our formula. Again, restate it again. And so let me fill in the dots here. We're going to connect the dots. So we got 1/2 times the 210, the 120.73 feet. Once we do that multiplication, that gives me approximation of 12,676.6. Or if you want to just round it off, this would be your answer. And remember to put it as square feet. Or another way you could write this as 12,677, and you say square feet like that. So there's two ways you can write it. And that's your final answer. And that's using area equals 1/2 base times the height, where you had to find the height using Pythagorean theorem. Now, remember the number we had before because we're not done because we want to compute the cost per square foot. So only thing you need to do is use the cost they gave us, which is 1,550, and then divide it by 12,677 square feet. In this case, once you do it, you end up with 0.122, and we don't have 3 decimals in our numbering of money, so you just say 12 cents per square feet, and that would be our answer, our final answer to the question. So there's 2 answers. One was how much square foot, and the other was how much it costs. Now, again, we're going to look at another formula. Now, the formula is not complete on this slide. I'm going to write into it so you get the right formula. But again, we want to find the area of a triangle, given, in this case, 3 sides. So if 3 sides are given to you, then you can find the area of a formula using Hero's formula or Heron's formula, however you pronounce it. And it can be used to determine its area. So Hero's formula or Heron's formula is basically say this. There's 2 parts to it. To find the area, A stands for area, is S times, there's an S in front of here, S times S minus A times S minus B times S minus C. Now understand little b, and little c are the sides of the triangle, like we talked about in other videos. You may want to look at some of the videos, how we set up triangles, how we draw them. But you may want to say, where does S come from? So this is where A stands for area right here. This is our final answer we want to get to. But in order to get that, we got to find S. S is equal to 1/2 A plus B plus C. So first find S. That's the first thing. And then the second thing, apply this formula. Remember, A, B, and C are sides of the triangle. So let's say we have a triangle that looks like this. Here's side A, side B, and side C. And to find S, S will equal to 1/2 when you add A plus B plus C. And then you apply this formula for the area to help solve it. So let's look at an example. Again, we use this when we have or given 3 sides. We not necessarily have a way to make something the height. We don't know the height, but they give us 3 sides. We use Heron's formula. So here's an example. So let's look at this diagram. And we're going to allow the slide to show us how to do the work and give us some numbers here. So we're given 3 sides here. 3 sides, 10.2, 5.12, and 7.84 meters. Now, it looks like they gave us a line that we can figure out the height, which is that JK, but we don't know it. But we cannot necessarily do Pythagoras' theorem because I don't know how far it is from here to here. It's not an equilateral triangle. It's not a isosceles triangle. And if it was, I'll be able to figure out the height, but I'm not able to figure out because I don't know how long that is. How long is this? I don't know how long it is. I can't just say it's half of 10.2 because it's not. So this is where we use this formula, Heron's formula, to solve for the area of a triangle. So to compute it, we'll start with our formula. Again, A is equal to S times S minus A times S minus B. This is times, put a dot here, times S minus C. Now, first thing we got to do is figure out S. So everybody add side A, B, and C, and then take half of that. That'll be our S value. So here it is up here. We add our sides, 7.84, 5.12, 10.2, add it, take half of that. We end up with 11.588. So in that case, I'm going to just put a check there. I'm going to use that for our formula that I wrote earlier. So let me show you how it's written in as a formula. So to compute the area, we know the area is equal to, I'm going to fill in the blank, 11.58. And what is happening here is we're multiplying. Now watch how I'm doing this. So I want you to write this down. 11 minus A, which is 7.84, times 11 minus B, times 11 minus C. And this here is my S. The first thing up here is my S. So if you're doing your calculator, I would say figure out what each of these values are. So for the first value, second value, and the third value. So the 11.58 would just come down on our second line. And then we do the subtraction of each of those grouped in the parentheses. So the first group would be 3.74, second group would be 6.46, and in this third group, we end up being 1.38. Multiply for these numbers, you end up with 386.093, and then you take the square root of that. So don't forget, it's in the square root. So our area will be 19.6 meters square. Again, since it's area, it's square or square meters. That is our answer for this particular problem. So don't forget, you got to take the square root when you multiply those four numbers, then take the square root. Now, the last problem we're going to do, we're going to bring it all together. We're going to find the area of this shape. It's a Gabriel roof in this figure, and then we want to round it off to 2 significant digits. So if you want to pause it and write this down and see how would you do it, you can try it on yourself, try it by yourself. My suggestion is to see different shapes and find areas of those shapes and then add it together to get the total area of this particular figure. Now, there's many different ways to do this. The route I may take for this today is divide this into 2 shapes. Here's one shape, which is a triangle on the top, and on the bottom is a trapezoid. Now, we know how to find the area of a triangle. The area of a triangle right here will be 1/2 the base times the height. Our base is in red, our line in red, and our height in this case will be here. Now we know the whole height is 18 feet. We know the height here is 10, so that makes this, the height just being 8. The base here is down here. This is our base, 22 feet and 6 inches. And so we got to make sure we keep our units correct and proper when we do this particular problem. A couple of things people do, they may convert everything into inches and then eventually back into feet to do it. Figure out what 8 feet is in inches, 8 times 12. We know that's 96 inches. Again, we do the same thing down here, or you can leave things in feet, but make sure we do it right. This is 20, the bottom 22.5, so we got to make sure we understand how we write that. Now for the second, number 2, the trapezoid, we know to find the area of a trapezoid, the formula for this right over here, let me write in a different color so you know I'm talking about a trapezoid, would be the area is equal to 1/2 again, the height times B1 plus B2. Now we know what B1 is. B1 is 22 feet, 6 inches. B2 will be 22 feet, 6 inches plus these outer parts, which each of those are 5 feet. Added together becomes 10 feet. So we're looking at 32 feet, 6 inches. And we know the height will be, in this case, 10 feet. So let's do one of the shapes first and figure out the area of one of the shapes and see what our slide would do for this particular problem. So it did the same thing. It divided into 2 areas. You could divide it into 3, 4 rectangles, 3 triangles, 4 triangles, but whatever you need to do, you will still get the same answer if you do the formulas correctly. So for the first thing we're going to do, let's do the trapezoid first, that section first. Now, as I said earlier, to find the area of the trapezoid part, I'm going to go back to that, just the trapezoid. Don't want to go ahead of ourselves, guys. It's equal to, if you remember, 1/2, the height was 10 feet. B1 is 32.5. And notice I said 0.5. I converted this to a decimal, plus 22.5 feet. Going back to our drawing. So I want to look at our drawing. This is our drawing. I'm going to clear the screen so you can see where we got these numbers. So this is R1 and this is R2 in this case. First thing we're doing is a trapezoid. So look at the diagram. Do you agree with that? Now, area is equal to 0.5, which is the same as 1/2, times 10. And we already did the addition. That gives us 55 feet. We do this multiplication, all these three numbers will give us, for right now I'm circling, but that's not my answer. This is my area of the trapezoid. This is the trapezoid area. So remember that number, it's not your answer. 275 square feet is my area. Now I got to find the area of the triangle and then add it to that 275 feet. Now again, let's go back to our triangle. Remember with the triangle, this is the top piece. Our base is 22.5, height is 8 feet. And so let's do this. And so here's our problem. So the area, and it's saying it right now, is equal to 1/2 8 times 22.5. Let's do the multiplication of those numbers. And we're with 90 square feet. What you're going to do, you're going to add that 90 to this 275. When we add that, we're going to end up with 370. And that will be our answer, 370 square feet. That is the area of the figure, because we broke it down into two, the triangle and the trapezoid. The trapezoid and the triangle. So that's our trapezoid area, and this is our triangle area. So I hope that helped to figure out how to find the area of a triangle using two formulas. And then we did a little complex shape to bring it all together with the different types of formulas that we learned from polygons and how to find the area of different polygons. Again, look over this video again, and even some of part 1 video of finding the area of a polygon. And if you need some more help, we have supplementary material on our MathLink website. Again, let MathLink bring it together. Thank you for watching this video.